Hi, hello everyone. So in this third video about vector product, we will continue our discussion about examples. So now we discuss example 4 until example 6. So in example 4, the position vectors of vector of point P and Q relative to the origin O is 2i plus 2j minus k and 4i plus 2j minus 2k. So in the first sentence, actually this vectors refers to OP and OQ. So here is OP and OQ from the first sentence. And then calculate the sine. The sine of the angle here means the sine theta. So remember the first video regarding the concept. So sin theta equals to magnitude of cross product divided by magnitude of its component. So here OP and OQ is its component. So before we move to the cross product, we find out first the magnitude of OP, which is 3, and magnitude of OQ, which is 2 times 6. Okay. Then we go to the cross product. So cross product of OP and OQ so will be like this. So no need to explain. From the previous video, I already explained in detail how to expand and calculate. Okay, so just straight away give the answer. That is negative 2i minus 4k. And then as I just said earlier, after we find out the cross product, you have to find out its magnitude. So the magnitude of the cross product, so calculate, then it will be 2 times 5. So after we already obtain all this information, then we can proceed with the sine of angle, which is sine theta. So this is the original formula. So later on we will make a sine theta as a subject. So sine theta as a subject will be like this. So magnitude of the cross product divided by magnitude of its component. So we just put it all these values, and then we just press your calculator and the calculator give the answer in terms of cert, that is cert 30 over 18. You can also give the answer in decimal. Okay, at least 3 significant figures. No problem. And then the other part of the question also asks to find the perpendicular distance. Okay. So from the angle POQ, so remember this angle POQ is actually angle between vector OP and vector OQ. So this theta, right? So from this angle, we know the size of OP is 3, that is the magnitude 3, and OQ is 2 times 6. But we don't want OQ just until the end, that is the point that point P will be perpendicular. Okay. So until point N, so actually we want to find out this distance, that is Pn. So this it will form this triangle. Okay. So OP, PN, and ON. So since we already know the sine theta from the previous questions, so we know sine theta is opposite over hypotenuse. So opposite here, straight away we can find out the Pn. So Pn over 3, the sine theta. So sine theta is 30 over 18. So the perpendicular distance, that is Pn. So 3 times sine theta, right? The sine theta is 30 over 18. So substitute and then simplify. Then we find out the perpendicular distance is actually 0.9129. Okay, or 3 significant figures, you can give 0.913 also can. Okay, 3 significant figures. No need to put unit. Okay, if you want to put unit, it's okay, but I'm not suggest you put anything, just the values. Okay, because you only focus on the values and the working step. It's not about the unit. Right, so that's for the example 4. Then we move to the example 5. Find the area of parallelogram. Okay, parallelogram, four sides. Okay, determined by vector u and vector w. So the area of parallelogram. So if you look at the formula in the first video regarding the concept, so you have to find out the cross product and later its magnitude. So first we find out the cross product u and w. So the cross product would be 2i plus 8j minus 7k. Then later we find out the magnitude of this cross product. So the magnitude of this cross product would be also the area of parallelogram. Okay, the area of parallelogram is actually the magnitude of the cross product. No need to divide by 2 or anything. Okay, the thing that divide by 2 is triangle, but this time is parallelogram. So straight away the magnitude of cross product would be the area of parallelogram. So find out the magnitude. So straight away we got the area of parallelogram, which is 117. Or if you press your calculator, the calculator already rationalize for you and give the answer 3 times 13 also can. Okay, no problem. Right, so next we move to the last example in this video, which is example 6. So given 3 points, that is point A, point B and point C. So these 3 points form a triangle. Okay, so first find the vectors AB and AC. So to find vector AB, so remember from this point we can find out the position vector. So to find vector AB, so we need to subtract OB minus OA. So this one is OB, this one is OA. So OB minus OA, that is vector AB would be negative 3i plus 2j minus 3k. So I don't want to put ijk, so just give your answer in H bracket here. Okay. And then also similarly for vector AC, so it will be OC minus OA. So again, I give you answer in this form, so no need to put ijk. So make sure it is a H bracket, not a normal bracket. The normal bracket is for coordinate, but this H bracket represent the vector. So it will be 0, 1 and negative 6. Or if you want to put ijk, so it will be j minus 6k only. Okay. And then next, after we find out AB and AC, then we find out the cross product. So the cross product of AB and AC, so this one is AB, this one is AC. So we expand and find out the cross product would be negative 9i minus 18j minus 3k. Okay, and then next, again after we find out the cross product, we find its magnitude. So use the formula of magnitude, and then we'll find out the magnitude would be square root of 414. And then to find the area of triangle, so for triangle you have to divide the magnitude with 2. So 1 over 2 times the magnitude of cross product, that is 1 over 2 times 414. So just straight away give answer in decimal, that would be 10.17. So that's the area of triangle. Right. Before we end our video, so just take a look at a few points here. The first one, the vector product of two vectors is always perpendicular to both its components. Later on in subtopic 5.4, this vector product is known as normal to its plane. And then secondly, the cross product operation is similar to the finding the determinant of matrix T times 3, with I, J, and K occupied the first row. Okay, I already stressed out this one in the second video regarding example 1 to example 3. And then third, after obtaining the vector product, we will determine its magnitude. Then we use the magnitude of the cross product to calculate first the area between two vectors, the angle between two vectors. So remember example 4, the sign of angle. And then next area of parallelogram or triangle, which is example 5 and example 6. Okay, we calculate these two areas. So this is actually we using the magnitude of the cross product. Okay, I think that's all for this video. So thank you very much for watching. So don't forget to do the tutorial. So make sure you fully understand before we move to the next subtopic. Because the next subtopic is the most challenging one in this chapter. That is the application of vectors in geometry. So until then, thank you very much. Bye bye.